Hello, grade 10 learners. Our topic is on relations among chords, arcs, central angles, and inscribed angles. At the end of this video lesson, you will be able to define circle and recognize its parts, define and identify arcs, central angles, and inscribed angles of a circle, and determine the degree measure of an arc, central angle, and inscribed angle of a circle. Now let's start. Let us begin by defining what is a circle. Circle is a set of all points in a plane equidistant from a fixed point called center. The circle is denoted by the symbol and is named by its center. So in this figure, this one is named as circle A. The radius of a circle, or radii in plural, is a line segment connecting the center to any point on the circle. On this figure, line segment OA, line segment OB, and line segment OC are radii of circle O. All radii on the same circle are congruent to each other. The chord of a circle is a line segment connecting any 2 points on the circle. Given the figure, line segment AB, line segment CB, and line segment FE are the chords of circle O. The diameter of a circle is a chord that passes through the center of the circle. It is the longest chord of a circle. The measure of the diameter is twice its radius. Given this figure, line segment BC is the diameter of circle O. Since the measure of the diameter is twice its radius, we can represent that using D equals 2R, or R equals D over 2. Second line is a line that intersects a circle at exactly 2 points. Since line S intersects circle O at A and B, then we say that S is a secant of circle O. Tangent line is a line that intersects a circle at exactly 1 point. The point of intersection is called the point of tangency. On this figure, since line S intersects circle O only at point A, then line S is a tangent of circle O. In this case, A is the point of tangency. Let us have exercise number 1. Given the figure, determine the following. Number 1, what is the name of the circle? That is correct. The name of the circle is circle S, since a circle is named by its center. Number 2, the center of the circle. The center of the circle is point S. For number 3, what are the 3 radii? Remember that radius of a circle is a line segment connecting the center to any point on the circle. That is why the 3 radii are SF, SD, and SE. For number 4, what are the 2 chords? That is correct. The 2 chords are DC and DF. Remember that chords of a circle is a line segment connecting any 2 points on the circle. For number 5, the diameter. The diameter of the circle is DF. Remember that diameter of a circle is the longest chord. It is also a line segment joining any 2 points on the circle passing through the center of the circle. For number 6, what is the secant? Very good. The secant is line R. Secant line is a line that intersects a circle at exactly 2 points. So we have BC as the point of intersection. For number 7, what is the tangent line? Very good. The tangent line is line S. The tangent line is a line that intersects a circle at exactly 1 point. And the point of tangency is point D. I hope that you got all the answer. Now, let us deal with the location of points of a circle. The three location of points of a circle are points on the circle, interior points of the circle, and exterior points of the circle. So, the points on the circle are the points of the circle whose distances from the center are equal to the radius. In this case, we have point A and point S. The interior points of the circle is a collection of all points of the circle whose distances from the center are less than the radius. In this case, we have point C and point F. And the exterior of the circle is the collection of all points of the circle whose distances from the center are greater than the radius. And we have here point E and point G as exterior points of the circle. Moving on, let us define what is an arc. It is a continuous portion of a circle. It is a part of a circle included between any two of its points. It is denoted by this symbol, and it is measured in degrees. A circle is in itself an arc that measures exactly 360 degrees. Arcs can be classified as semicircle, minor arc, and major arc. A semicircle is an arc which is one half of a circle. It measures exactly 180 degrees. A semicircle is named using 3 points. The first and the third points are the endpoints of the diameter, and the middle point is any point of the arc between the endpoints. In this case, we have arc DFE and arc DBE as semicircles. Minor arc. Minor arc is less than a semicircle, and its measure is between 0 degrees and 180 degrees. A minor arc is named using the two endpoints of the arc. On this case, we have arc DF, arc FE, arc EB, and arc BD. Lastly, we have the major arc. It is greater than a semicircle which measures between 180 degrees and 360 degrees. A major arc is named using 3 points. The first and the third are the endpoints, and the middle point is any point on the arc between the endpoints. So on this case, we have arc D, B, F, and arc F, E, B. Let us deal with exercise number 2. Identify whether the given arc named is a minor arc, a major arc, or a semicircle. To begin with, let us have arc BF. So this is arc BF. And this is, very good, a minor arc. How about arc DS? So this is arc DS. And this is also a minor arc. For number 3, arc BDS. BDS. That is correct. This one is a semicircle. For number 4, we have arc BFD. BFD. That is correct. This one is an example of major arc. For number 5, arc DF. DF. That is correct. This one is a semicircle. For number 6, we have arc DSB. DSB. Very good. This one is a major arc. For number 7, we have FS. Arc FS is an example of minor arc. I hope that you got all the correct answers. And let's move on. Let us define what is a central angle. The central angle of a circle is an angle whose vertex is the center of the circle and the sides are the two radii of the circle. So given this figure, we say that angle AOB is a central angle since its vertex is at 0, which is the center of the given circle, and the sides OA and OB, which are the radii of the circle. The arc between point A and point B is called an intercepted arc. The intercepted arc is created when lines or subsets of a line cuts across a section of the circumference of the circle. Remember that the degree measure of the intercepted arc is equal to the corresponding central angle. So therefore, if the measure of angle AOB is equal to 80 degrees, then the measure of arc AB is also 80 degrees. Moving on, the arc addition postulate states that the measure of an arc formed by two adjacent non-overlapping arcs is the sum of the measures of the two arcs. So given the figure, the measure of arc AB plus the measure of arc BC is equal to the measure of arc AC. So for example, if the measure of AB is 80 degrees and the measure of arc BC is 60 degrees, using the arc addition postulate, we have 80 degrees plus 60 degrees, and that is equal to 140 degrees. Let us work on with exercise number 3. Refer to the figure and find the missing measures. For number 1, the measure of angle BOC is equal to 60 degrees. What is the measure of arc BC? That is correct. The answer is 60 degrees. Since the degree measure of the intercepted arc is equal to the corresponding angle. For number 2, the measure of arc FE is 85 degrees. What is the measure of angle FOE? Very good. The correct answer is 85 degrees because the degree measure of the intercepted arc is equal to the corresponding angle. For number 3, given that arc DE is 60 degrees, what is the measure of arc FD? Since we know that FE is 85 and DE is 60, so therefore, by simply adding 85 plus 60, the measure of FD is equal to 145 degrees. So for number 4, what is the measure of BF? If the measure of BOF, the angle BOF, is 95. That is correct. It is also 95 degrees, since the corresponding angle is equal to the degree measure of its intercepted arc. Okay, for number 5, given the measure of arc BFD, BFD D is 240 degrees. What is the measure of arc BD? So we know that the total degree measure of the arc is 360 degrees. We just subtract 240 degrees from 360 to get the measure of BD. That is why the measure of BD is 120 degrees. Let us now deal with inscribed angle. An inscribed angle is an angle whose vertex lies on the circle and the sides contain chords of the circle. On this case, we have line segment AB as a chord, also line segment BC as another chord, and we have the vertex which is on the circle. So we say that angle ABC is an inscribed angle. And arc AC is the intercepted arc of angle ABC. So in an inscribed angle, the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So therefore, if the measure of arc AC is 80 degrees, then we say that the measure of angle ABC is 40 degrees. Let us deal with exercise number 4. In circle C, the measure of angle XCY is 164. Find the measure of number 1, arc XY. Since the degree measure of the intercepted arc is equal to the corresponding central angle, since angle XCY is a central angle, therefore, arc XY is also 164 degrees. For number 2, what is the measure of angle XWY? So this is XWY. Knowing that the intercepted arc is 164 degrees, we just get 1/2 of 164 to get the value of this inscribed angle. That is why the measure of angle XWY is 82 degrees. Same is true with the measure of angle XZY. Since the intercepted arc is 164 degrees, we just get the half of it. So the measure of angle XZY is also 82 degrees. Well, that's all for today. Until our next session, thank you and enjoy learning.